So the first one's not too bad, right? Move that 11 over. What are the two steps here? So -3, good, and then 9. So that's what I put here. And I better put it there too. That's the easiest mistake to make, really, is to forget the other side.
Yeah.
And then I know, continuing the equation, this becomes good. X minus 3 squared equals 20. Yeah, put that plus or minus the minute you do it. What can you do with root 20?
Root 5.
2 root 5, 11. 20 is 4 times 5, square root of 4 is 2. Now, the biggest mistake I see here is from here to here it becomes this. That 2 can't jump over that. I can't suddenly decide I don't want to multiply anymore. Too damn bad. This is square root of 4 times square root of 5. The answer better still be multiplying by it. It can't jump over that plus or minus. You with me? Okay. And then the last step. Add 3 over and I'm done. Because there won't be any like terms. Good. So if it was 3 plus or minus 2, don't stop there. You can actually go further. You got like terms. But if you don't have like terms, you can't do anything. Stop. So what about the ugly one? Poor little dude. Completing the square was created on the assumption that the first coefficient is 1. So if it isn't, you got to make it that way. So the second dude, very first thing is to divide by 9. Oops. Okay. So that's what we're working with.
Mario.
That's the giveaway. All right. Use your time for what you want.
That's 3 over 2.
Good. So the 2 steps. 3 over 2, cut 3 in half. Then what do you do with that?
9 over 4.
Good. Square it so you get 9/4. Good. No C shift. Add 9/4. That tells you what to add. That tells you how this is going to factor. Good. And then here you need LCD, so you get 20 and 81. Good. And I tell my students when I first teach them cross multiplication, they want to do it everywhere. And of course it only works truly in one place, when you have a fraction equals a fraction, right? But I just basically, I don't know if you guys saw me, I cross multiply. There is no common stuff here. So 4 times 5 is 20, 9 times 9 is 81. As long as you remember, the bottom is going to be the product of these two. So you can modify cross multiplication and use it in a lot of other places if you do it right? Or just get freaking LCD and go. Now I'm at a familiar spot. Good. Plus or minus? Good. What's the square root of 101? Don't know. So that's still that. On the bottom, I have the square root of 36, which is 6. Good. So that can't suddenly come up top. It is on the bottom, so its answer will be on the bottom. And one last step, really, unless you want to get those things together.
Do we stop here or we have
Yeah, you could either stop here or you could combine them if you want to. Either answer I'll take. Yeah. You could multiply this by 3, there'll be LCD. You can put it all over 6. Right? So, or, like I just said, either way. So you multiply this by 3, you can make this -9 plus or minus root 101 over 6. Yeah.
You really don't care if we write, like if I did it plus or minus square root of 101 minus 9? Not obviously.
Oh, it doesn't matter.
Okay.
Yeah, it doesn't matter.
Okay.
It's just the plus or minus symbol, when it's in the middle, it's harder to mess it up. I don't know if that makes any sense. If it's out front, you sometimes could lose part of it or something. It's just, screw it. Something you pick up over a lot of doing math. So This is like listening to your doctor. What would your doctor do? Let me listen to what goes. Whatever he does, I'm going to do the same damn thing. So that's my suggestion. Okay. So obviously, answers to some of these could come out complex, and they wouldn't be. If this would have been negative 101, I would have just wrote I squared root of 101. It doesn't really affect the problem that much, right? It's just now I'm going to look at graphically how these answers kind of relate. So we just got two real answers, right? Mm-hmm. We got two real answers, which means my parabola. Right? If I pull this back over, I have this parabola, right? There must be how many places where it would equal 0? How many answers do we get? Two. So it must be two places. So it must be something maybe like this. Would be the minus blah 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 blah. This would be the plus blah 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 blah. Just gonna have a smaller one, and it doesn't have to be negative positive, just a smaller and bigger. What's a way that I can have no answers, no real answers, where it would be an I there? What would happen with the parabola?
Real and imaginary? It doesn't.
I want two complex numbers, right? What would happen? There should be no real answers. How could there be no real x-intercepts?
All there.
The parabola just does what?
Over.
Yeah, it just never gets there. Right? There or something. You with me? So if you get a problem where you get two complex answers, this is the situation you're in. It just doesn't hit the x-axis. Very simple, right? It's like if I'm trying to solve the x-intercepts and I get complex numbers, not real, then it's not going to hit the x-axis on the real graph. Okay. And then the one situation we haven't seen really yet is I can get one exact answer. What would have to happen if I want to get one answer? Let me say it a different way. I get one answer repeated, really. The parabola would have to touch the x-axis. To get one answer, it has to touch once. So it has to actually sit on the x-axis. Right? You can do this, Jeff. So then this would be something like that. Right? What's the only answer? The only answer is 3. It's the only way to make this 0, right? So you get one answer. This parabola would sit on the x-axis. You guys kind of with me? Mm-hmm. Okay, I'm hopeful. Now, one little thing I want to make really clear now that I didn't just now do is there is 0 way to get one real answer and one complex. And why is that? I mean, if I look at the way these things look, they look sort of like A plus, how do I want to screw you guys up? Where would the complex number go if I had one? Where would the I be?
Outside of this, where
Here, where there's plus or minus, right?
Yeah.
So either there is an I there, and I get two complex numbers, or there isn't, and I get two real numbers. There's no damn way in hell you're going to get one real and one imaginary. Are you with me? Mm-hmm. Okay, so complex solutions. Uh-oh, this sounds like a note. Complex solutions. I'm not going to make it overly qualified here. Complex solutions always show up in conjugate pairs. Right? The short, too long, didn't care. There's always two complex number answers. Right? You never have one complex answer. You guys with me? No, I like it. So for example, if I had a very quick little one, if I had x squared, I want to freak you guys out a little bit.
So just subtract 9.
Okay, good. You could subtract 9.
Square root.
Square root. Plus or minus, yeah, 3i. Right, so they're always going to show, because they're always going to be related to the plus or minus, because that's where my radical is, right? They're always going to be at the plus or minus. There's always going to be two of them. There can't possibly be one of them. But we just saw a situation where I could have one real answer, right? It's just repeated. X minus 3 squared equals 0. There's one real answer. It just shows up twice. But you always have to have a pair of complex number answers. You can't just have one by itself. Okay, good. Here's the part that's going to freak you guys out. Factor this. That's the other way to solve it, right? Factor it. Don't tell me you can't.
Quick question, if you write x equals plus minus I3,
You're still right technically, but it's sort of like saying x3 instead of 3x. The only reason I put it in front of the radical is so it doesn't look like it's inside the radical, right? Yeah. So how do you factor this? If you do this, you're wrong, of course, right? We know that. We're supposed to not be able to factor this over the real numbers. But if I'm allowed to use complex numbers, I can factor this all day long. Because the reason I can't do it with real numbers is there's no number squared that comes out negative. But now we know numbers that come out negative when you square them. They're the complex numbers. So instead of 3 and 3, I put 3i and 3i, which goes along with the answers we just got, right? If you factor this and it's equal to 0, what answers do you get? 3i and negative 3i. So expect a question from me where I ask you to factor like x squared plus 16. I'm going to say factor this. And you have to use complex numbers to do it. Right? So I'm going to ask you to factor something like this.
So if you FOIL that out, it's going to equal that.
Totally. Because remember, how do you divide complex numbers? You multiply by the conjugate of the bottom, right? So that the complex parts cancel out. So these are conjugates of each other, aren't they? Yeah. X plus 3i, x minus 3i. So the middle term, the only place a complex number could still be, cancels. You guys see that? So I get, if I multiply this back out, I get x squared minus 3ix plus 3ix. And then what's 3i times negative 3i? And I squared is, oops, what am I doing? I squared is negative 1, so then I end up with plus 9. Yeah?
How did the positive 9 turn to negative 9? Like, when you square it.
Oh, so I subtracted to get it to the other side, yeah. Good.
And I have a question.
Yeah.
You know how there you said like 3i squared is negative 1? So
Yes.
Like, and then what about the other one, like x plus or minus 3i will be like square root of 3? Because I equals square root of negative 1?
Yes, and?
You want to simplify to a... You know how from...
Oh, you want to bring it back?
Yeah.
Oh, okay. All right, so you got to be careful. If I have a 3 in front of a square root of negative 1, I can't just put the 3 inside. You have to think backwards. 3 is the square root of 9. So now you force it to have the same root, and then you could put it back in. Square root of what is 3? 9. So if I want to put it in, it's got to be the square of itself for it to make sense. Is that immediately necessary to understand? No, but it's a cool little thing to realize. Yeah.
so if it was x squared plus 16, then it'd be x plus or minus 4i, but then since it's 4i, it'd just be 1. So it'd be x equals plus or minus 1.
Wait.
Because 4i is equal 1.
No,
I
I
to the fourth equals 1.
Oh, okay.
4 i's is just 4 weird things.
Okay.
Yeah. So you gotta be careful. That means multiply. That means raise it to a power. Right? So this means adding I 4 times. This means multiplying I by itself. Yeah.
We have problems like that in the homework.
Yes.
The 3i.
Totally. They might not say factor it.
Oh,
I
okay.
can't remember off the top of my head. It'd be really cool if they did, but I doubt it. But I'm telling you right now that I will ask you to factor it. All right?
Okay.
And if you want to complain that it's not in the homework, it's too bad. I'm not going to listen to that. Just to let you know. Okay. Yeah, they don't have any just straight up like that. That's all right. They have several that you could do that way. That if you did it that way, I would love it. Right? You could, instead of this way, you can do it that way. Yeah. Both ways end up with the same answer.
So if we were to factor, I mean, if we do it the original way of subtracting 9, since we've already got those questions, the answers right there, just throw them over.
Yeah, if I said factor this, one way to do it is to solve it and then throw the answers into there. Totally. Right?
Can it get any more difficult factoring it like that? Like, will you make it any more?
I could have put a 4 there or something.
Okay.
It's got to be a squares, but now we can handle sum of squares. We didn't used to be able to. Now we can do it because we know complex numbers.
And if you put a 4 there, I would have divided it by 4 first.
No.
It just works.
So how do you factor 4y squared plus 81? 2y, 2y.
9.
Yeah, minus 9i plus 9i. Cool. It's kind of nifty.
That's it.
That would be the factor. If I said solve this, then you can take each one and solve for y, right? 2y minus 9i equals 0, or 2y plus 9i equals 0. And then you keep going. The process doesn't care. That process, same process we always use. We care, though, that there's little weird shit inside. There's some complex numbers, but the process doesn't care. Factor, set each factor equals 0, solve.
So y would equal 9 over
Plus or minus
2.
9i over 2.
Like it. So you get positive 9i over 2, then you get negative 9i over 2. Sweet. Okay. Alright. Let's do this. I want to do one more thing and then we'll take a break. Or do I want to do one more thing?
This is still 13-1.
Yeah, 13-1. I got something that's going to take about 10 minutes. You want to take a break now, or you want to do that and then take a break?
Now.
No.
Take a break now? Okay. Take a break now? Take a break later. All right. Let's see. Nah. So now we're going to do something that I want to stress right now to you. I'm going to show you where this comes from. You're never going to have to do this yourself. But I do want to show you. It's like every student must be exposed to this derivation. That sounds horrible. I expose you to this radiation. See what
So
happens.
this won't be on the quiz, but it's
No, if I put something like that in the test, it would be a bonus question. But I mean, this is where the quadratic formula comes from. So about half of you guys know it. Right? So I don't know if you know where it comes from. It just came out of somebody's ass? No. Sometimes it seems that way, but it actually came from a valid place.
It's still 13.
This is 13.2 now.
All right. Moving on.
So the part the students hate about this, and I can't fault you for this, is there are no numbers in there. A, B, and C would be where the numbers would go. But I want to do something. I want to solve this equation. If I solve this equation, I have solved every quadratic equation in the universe that you can think of that exists, that doesn't exist yet, whatever. You with me? Sweet. So that's kind of powerful, and that's why it's a little bit gross, because it's doing an infinite amount of work. But what do I have to do first if I want to solve this? Beautiful. I got to divide by A, because I can't. The only method we know to solve this is completing the square. Can you factor this?
Not yet.
Yeah, what do I multiply to get C? It adds to be AC. Screw that. I don't know. Shit. So the first thing I do is divide by A. By the way, don't write notes for this. It's all in section 13.2, the whole thing. I just want to go through it with you. Right, so just pay attention. As much as you can. So now I've got this beautiful thing. What can I do at the same time? What do I have to do here?
minus.
Yeah, make some room here, right? Okay. So see how math again, I keep saying this because I don't know if you ever trust me or believe me. The process does not care. It doesn't care that there's no numbers. It doesn't care there's A, B, C. The process is the same. Divide by that dude. Make some room. What's the next step now? Yeah. Take half of B over A. So half of B over A. This is what you do when you have a fraction here already.
Yeah.
You don't divide by 2 and have this complex fraction. You say 1/2 of B over A is
B over
B over 2A. And what do I do with that?
Square.
Squared. Well, what's B over 2A squared?
B squared over 4A squared.
All right, let me know. Have I already lost anybody? I want you to realize that what we're doing right now is the same damn thing we've been doing. There's just A's, B's, and C's in there. Right? So what does this tell me here?
Add b squared on 4a squared.
Yeah, that I have to add to both sides. How we doing? That's what the process says.
X plus b over 2a.
Yeah, so now how does it factor? It factors using this, right? Kicks ass. So I don't have to even think about this ugly thing. I just know it factors like x plus b over 2a. What do I get on this side? What do I have to do over there? And bring in another color even. Ooh, yeah. What's the LCD here? What does he need?
He needs
He's a 4a. 4a. So then I get negative 4ac plus b squared over 4a squared, right? So I get b squared minus 4ac. Anybody who knows quadratic, that should look very familiar. Over 4a squared. That doesn't look familiar yet. Not done, so sorry. That looks remarkably disgusting, but it hasn't actually been any harder than any problem we did earlier that actually had numbers in it. It really isn't.
A squared. Both sides.
Yeah, so now the step is square root. Okay. So let's see where we are now. So square root of this
B over 2A.
equals, what can I do here? Can I do something at the top?
No, put the bottom.
Yeah, square root of b squared minus 4ac. What's the square root of 4a squared?
2A.
2a. And a real quick word about that. Square root of a squared is actually the absolute value of a, right? Which is plus or minus a, but you see how there's already a plus or minus built into that term? That's why I don't have to worry about putting the absolute value in there. You with me? Maybe, okay.
Subtract B over 2A.
Yeah, so now subtract b over 2a. And they're already both over 2a, so I get x equals negative b, give or take, b squared minus 4ac, all over 2a, and there is the quadratic formula. One quick thing. Let's do one quick concrete example before we take a break, just so we can see what the hell that thing is used for. That means, if I have an equation like this, if I know what a, b, and c are, I just plug them in the right place, and the answers come popping out.
Instead of doing all of that.
This is just where that came from. That's why to use this is so quick, because we just did a whole bunch of freaking work to get there, right? So instead of doing this for every problem, I could just start there when Jeff says it's okay. Yeah.
That's not fair.
On the test that you ask us to plug it in quadratic.
Yeah, I'll say use quadratic formula. Somewhere else I'll say use completing the square.
And
A really good point, if I'm a student right now, you guys are thinking this, why the hell, I almost said something else. Why the hell would I use completing the square like we just did if I got this bad boy? Because completing the square is useful in so many other places. I need you to get practice with it now, and that's the only place you can practice with it yet. So that's too damn bad if you don't like that. You got to trust your teacher. There's a method. So here's an example of using this. Alright. So is that factorable? No. Please try not to always use quadratic. If it's factorable, you should factor it. Alright? Don't just automatically throw stuff in. Of course, to stop you from doing that, I'm going to have part where I say solve by factoring. I'm going to have. So I can't factor this. There's no way I can get factors of 3 to make 5, so screw it. So what's A, what's B, what's C? What's A?
3.
What's B?
5.
Say B again? Negative 5, good. So negative 5. C is 1. And now I just got to plug and chop. So X equals negative B, so negative 5, 5, give or take, square root, B squared, 25, minus 4 times A times C, all over twice A. what I've been showing. So then I get 5, give or take. 25 minus 12 is 13 all over 6. Okay, so we'll just stop right there. That looks like an answer we would get if we completed the square. And of course it does, because that's where this came from. This came from completed the square. It's going to have the same kind of form answer. So let's take a break. Come back, 5-2.